Okay. I hate when it does that. It's like it just wants to write no matter what. All right, there we go. All right, number 21. So we have described the charges on the proton, electron, and neutron. So we got that. Proton is what? Positive. Electron is what? Negative. And neutron is what? 0. Okay, so +1, you should probably put the ones. +1, -1, and 0. And that will help you out a little bit more with those questions. All right, name the 2 subatomic particles that have nearly identical mass and size. I've asked you this now twice. Protons and neutrons. So remember, we're not asking about charges on that one. We're asking about the size and their weight. That's why we use them for mass numbers. All right. Why do we list most atomic masses as decimal numbers instead of whole numbers? Why is the average atomic mass a decimal?
Because there's no there's different there's a little diagram with the little circles.
Yep. So we have isotopes. So isotopes. So different isotopes. But what kind of average is it? So I underlined the word average because that's what they're asking. It's a weighted average. So I ran out of room. I hope you guys might still have room. If you don't, just write it sideways. All right, weighted average. It's not just adding up all those isotopes and dividing by the number you have. It is saying how much is their abundance and using that to say how much they're contributing to that decimal number. So it is a weighted average. So again, that is average atomic mass. Those different isotopes are weighted. Then they have different percent abundances. All right. So atomic number of an isotope of bromine. So we have an isotope that kind of tells you neutrons are going to be crazy, but bromine is 35. Okay, so the atomic number of bromine, 35. You can look on the periodic table. That's what it is too. So I'm going to write Br, put 35 down here. The mass number is 80. I'm just practicing my nuclear notation right now. What are the protons, electrons, and neutrons? So what is the proton? 35. What is the electron? 35 as well, right? If we had an ion, if I had a -1, right? So if I had bromine -1, what was the electron? Sorry, it would be 36. Good. That is a 1. Oh my gosh. The electrons would have been 36. Okay? So if you have an ion, that's when things change. But this one is neutral. So what are the neutrons? 80 minus 35. What is it?
45.
Thank you so much. 45. Good. All right. So now this is an average atomic mass question. So the element copper has 2 isotopes, 63 and it has an abundance of 69.15, while copper 65 has a percent abundance of 30.85. So this is really mean because we didn't put percents next to them just to confuse people, I'm assuming. So we're going to put percents right there. We're going to calculate the average atomic mass. So first thing, we take percents and do what? Move it to the left, right? So we're going to say that 69.15%. We're going to change it to be 0.6915. The next one was 30.85%. Tomorrow I will make sure they all have percent signs on them, not to throw you off, okay? Only move the decimal to the left on those. All right, so this one we have 0.3085. All right, now what's the next step? We multiply it by what?
63.
Yep, we multiply it by their mass numbers. So if we're giving it to you this way, remember mass numbers are in the isotope name. So 63 for the first one, 65 for the second one. We're going to get those answers. You should go to about 2 or 3 decimal places. As long as, try to make the decimal as long as possible so that your answer becomes more accurate. Okay? So 0.6915 times 63. Did you guys get 43.56? Good. 43.56. I'm going to go one more decimal place. 5. I rounded the 4 up. And then, gosh, you guys can totally not see that. I'm so sorry. There you go. And then the other one, what did you guys get for the other one? 20.05. Was there one more number after it all? 2? Okay, cool. What's the last step? we're adding those two numbers together. We get the answer 63.617, and this is the one where you put AMU, the little decimal version, okay? 63.617. Okay, number 28. 28 is nice because we have a nice little table there, okay? So we gave you the isotope, but we also gave you a mass. So question, if we go through the trouble to give you a mass, do you use the mass number? No. For this kind of calculation, we had to use the mass number because that was all that was given to us in the problem. Do you see the difference between these two problems? This one, we actually give you the mass of the isotope. You need to use that one, okay? All right, so this one, we have to do average atomic mass again. So first step, we're taking all of our percent. So you basically kind of ignore this, all right? Because we gave you a mass. If we give you an accurate mass, you use it. So we're going to take our percents. We're going to move that decimal 2 to the left. Good. So we're going to go to the first one. I have 0.99300. The second one, I have 0. How many zeros are going to be in front? 2, because we're moving it 1, 2 to the left. So 0, 0, 7, 0, 0. Lots of zeros. Fun. Step number 2, we're multiplying it by who? Those masses. So we're going to take the 238.05 and the 235.04. We're going to get those answers. So I can give you guys the top one if you want to give me the bottom one. Yes. Let me go one more minute. So for the top one, I got not a good answer. Yes, I did. Sorry. 236.384. What did you guys get for the bottom one? 1.615? 45. Then the last step is we add those guys together.
238.0292.
You're awesome. Thank you. 238.0 blah 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 blah. What did you get?
What was it?
I just forgot it.
292.
292. So thank you so much. AMU. All right. All right. So I will continue recording these videos for the back of this review, so you guys can check those out later. You have your test tomorrow. Good luck. You'll do great. Enjoy your game tonight. Good luck at that too.
Enjoy your life.
Thank you. Thank you so much.